You own some sort of technological device, don't you? Ever thought of better ways of integrating these devices into the biomedical field? Research shows how implantable bioelectronics enhance people's health needs. We will look at the way we can generate a current with a laser emitting diode to operate a pacemaker used to regulate the beating of the heart. This is called optical charging. Why do we use optical charging? To sum it up in a diagram, it is to convert received radiation into a current to operate the pacemaker. We will be looking at this step by step. Laser diode typically emits a radiation in the near-infrared region of the electromagnetic spectrum. We can see that the magnitude of the wavelength of the IR radiation is 10 to the minus 5. Light typically has low interactivity with biological tissues. That is why IR radiation is used. Let's see why mathematically. We can calculate the energy that the wave releases with the following Planck equation. E is equal to hc over lambda. With E the energy in joules, h Planck's constant, c the light velocity, and lambda the wavelength in meters. We can deduce that the smaller the wavelength lambda in meters, the more energy is released. Therefore, a larger current is generated to operate the bioelectronic device. They need to fit in the tissues of the heart in the case of the pacemaker. This energy in joules is then converted into electricity with the help of photovoltaic cells, generating a current measured in amperes. The current is then transferred to a charge controller, which limits the rate at which electric current is added to an electric battery. The electric current is then transferred to a battery system that will generate a DC direct current. A DC current is an electric current flowing in one direction only. Finally, this will help the pacemaker function. As we have seen, optical charging can be very effective in the biomedical field, notably for implantable bioelectronics such as pacemakers. Such innovative technologies enable next-generation healthcare.